All right, so this is the solution to the ninth problem in the grind 75. This is flood fill. So to refresh our memory, basically we're given an m by n integer grid, and we're given an initial row and column, so initial spot in that grid, and we want to perform a flood fill, which is essentially taking note of the color of our initial spot in the grid and changing all other spots in the grids that are adjacent to it, meaning up, down, left, or right, to our target color, which is given to us in the function. And we want to do that for every pixel that is adjacent to that current pixel, and then we want to do that to every pixel, so on and so on. So for example, our starting one is this pixel at row 1, column 1, so row 1, column 1, and we want to change everything that is 4 directionally adjacent with the same number to our target number of 2. And so these have the same number, so we're going to change, so these have the same number, so we're going to change them to our target value of 2, and then we're going to move on to those values and update them accordingly if they're 4 directionally adjacent numbers are equivalent to the number that we started out with, which would be 1. So the approach that I had was actually correct. It was just syntactically sort of or pretty messy. And I forgot to account for one crucial thing, which led me to a Stack Overflow error. So we're going to do this the right way from the get-go. So first off, something we want to note is that if we look at example 2, actually, if the element at our starting row and column has this same color as the color that we're trying to change to, then we're not going to make any changes, as per this explanation. So that's the first check we want to make. So if image at our starting row and our starting column is equal to our color, then we are going to want to, we're going to want to return image as it is because no change needs to be made. Otherwise, we're going to change as we mentioned above, and then we're going to want to return image. So how do we want to change? Something that we need to keep track of, which is not given to us in the problem, is the color at that starting index. And because we need to keep track of that no matter what spot in the grid we are at, we're going to have to make a separate function that can continually take that value as we make more calls to it. So we're going to make another function. This one doesn't really have to return anything because we're just going to be altering that same object. And we can call it flood fill logic, as I called it when I was doing this problem. And we're going to pass in everything the same, except now we're going to pass in, we can call it match, and then we're going to pass in the appropriate color that we want to change to. Okay, so yes. So we're going to look at our illustration really quick to see what nodes exactly want to change. So this was the first example where our initial value is 1, 1, this one right here, and we want to change everything that is 4 directionally adjacent and is also a 1. And all the possible alterations we would be making would be a -1 for the row or +1 for the row, and then a -1 for the column or a +1 for the column. And so those are the 4 changes we're going to make. But what I was doing was doing a certain check before each one of those, and then making the recursive call. But it's actually a lot more concise if we just do all possible checks beforehand and then make the recursive call. So I will show you what I mean by that. So we're going to do a gigantic if statement, and what that's going to check is if the current node, or I keep calling it a node, but the current spot in the grid is, we want to make sure that, say, the row is within bounds. So that's the most important thing from the get-go. We want to make sure the element that we are going to check is within the row and the column bounds. Because if we call image with some row and some column that is outside of the bounds, then we're going to get an error. And to avoid that, we want to do all checks of indices beforehand. So, for example, we want to make sure the row is greater than or equal to 0. So actually, if it's the case that it's not, so say it's less than 0, or the row is greater than or equal to image.length. We can just do a similar thing for the columns. So, or column is less than 0, or the column is greater than or equal to image at, let's say, 0 dot length, because we need to have, a minimum of one row, not necessarily a minimum of columns, but the smallest grid we can have is a 1 by 1. It seems like we can't have one row without having one column. So we're going to do all of that. So that's to check if it's within bounds. But we also want to check if the color is the same as the initial match, meaning the grid space that we start on has 1. Anything we check against it should also have a 1 for us to change it. So we're not going to change a grid space with 0. So we're going to do this by checking if image at our current column and our current row and our current column. Let me actually just push this down here. Is not equal to the color, or not the color, to the appropriate color. And if any of these conditions are true, that means we've hit some sort of boundary, and we don't want to make any alteration if we pass the row and column checks, or this index is out of bounds. So what we're going to do is just return, because we know that we want to stop here. Otherwise, we want to make all the appropriate recursive calls to flood fill logic, as mentioned when talking about the graphic. So the +1, -1 for rows and columns. And let's just switch back over. So what we're going to do is call flood fill logic on same image. Maybe this time we'll do source -1, keep column the same, keep match the same, keep color the same. We're going to want to do the same, but maybe source +1. Sorry. Same, but this time we're going to keep row the same and decrement the column, and then increment the column. So this is going to check in every direction, and if any of the grid spaces at any of those places, again, doesn't match, any of these conditions or fails any of these conditions, then we're going to want to return. And we have to actually call this helper function with our original starting row and starting column. So just going to pass an image, starting row, starting column, and appropriate color. And this should be good unless I've made some syntax errors, but let us check. I'm going to run the example. Let's see, did I spell something wrong? Flood fill logic, image. Yeah, I forgot to add the appropriate matching color, which would be image at starting row and starting column. Okay. Missing comma. Let's see. Right, so I forgot to make the actual change, which I was starting right there. If the current grid space they were at doesn't fail at any condition, then we obviously want to change the color to our new color. And so we're going to set it equal to color. Let's run the cases. Let me see. All right, I also made a mistake right here. I forgot to, should have been does not equal the match, because if that's the case, then we want to return. If it's matches, then we want to make the appropriate change. So this should pass the example, and it should also pass the question. Let's see. Yes. All right, so that is the solution to ninth problem of the grind 75.